All right, hello everybody. Today we are covering day 5 on rectangles. And first off, we're going to review parts of a parallelogram, specifically the characteristics of a parallelogram, because a rectangle falls under the category of parallelogram, meaning all of the properties that apply to a parallelogram also hold for a rectangle. So first off, we know that there are two sets of opposite parallel sides. So we can just say two sets of opposite parallel sides. Okay, we also know those opposite sides are congruent for a parallelogram. So we also have two sets of opposite but congruent sides as well. Okay, properties pertaining to the angles. We know that opposite angles are congruent. So opposite angles are congruent. So the two sets would occur as F and H, and then angles E and G. Angles that are consecutive or adjacent to one another add to 180, so they are supplementary. It's another property. And then we know that finally our diagonals bisect one another. So diagonals bisect each other. So again, these are properties of parallelograms. They also extend to rectangles because by definition a rectangle is a type of parallelogram, just a more specific one. So that kind of leads us into our definition. So a rectangle is already a parallelogram, but we say it's with 4 right angles. We'll say a parallelogram with 4 right angles. That's what makes it different than a general parallelogram, but all of the other properties hold, meaning opposite sides are congruent, opposite sides are parallel, adjacent angles add to 180, opposite angles are congruent as well, diagonals bisect each other. And then furthermore, we know that diagonals of a rectangle, not only do they bisect each other, because it is a parallelogram, so they do bisect each other, but they also are going to be congruent. They literally have the same measure. Okay. So getting to just logic here. Rectangle is a parallelogram. We said true. By definition, it is literally falling under that umbrella term. Parallelogram, always a rectangle, false. Because if I have a parallelogram without right angles, it's not a rectangle. So it must have 4 right angles in order for it to be a rectangle. But that's not the case of a parallelogram in general. Okay. For matching, all sides are congruent. We have not talked about all sides being congruent for any of these. So none of these are going to work. That's actually for future on squares and rhombus, the rhombuses, the rhombi. All angles are congruent for rectangles because they're all 90 degrees. Diagonals are congruent in a rectangle, like we just said. Okay, opposite angles are congruent for a parallelogram, and because rectangle falls into that category, a rectangle as well. Sum of interior angles adding to 360, that would be a quadrilateral, which is 4 sides, also a trapezoid, also a rectangle, also a parallelogram. So because these are all 4-sided figures, they will all have interior angles adding to 360. Cool. Now let's look at some application. Okay, if this is a rectangle, then we know that opposite sides are congruent. So this is 12, this would be 12. This is 5, this is 5. Okay, 58 here would be 58 here. Alternate interior angles, and we know that there's going to be a summation to 90 degrees total. So 90 minus 58 is going to give me 22 degrees here and here. And then we know that these are just right angles. So it does help to fill in the diagrams first before attending to the details. Right? So measure of angle D, like we said, 90 degrees. Measure of angle A, also 90 degrees because all angles in this rectangle add to 90. BC is 5, DC 12, AC, this one's gonna be a little bit trickier. So this is actually the diagonal, which maybe we actually explore this triangle instead because the diagonals have to be equivalent. We're going to have to actually use Pythagorean theorem here, where I have legs of 12 and 5. So 5 squared plus 12 squared equals the, we'll call the c squared. So we have 25 plus 144 equals c squared. So it's giving me 169, which square rooted is 13. So if my diagonal that's highlighted is 13, diagonal in the other direction, AC, is also 13. Okay, measure of angle CBD. We have a lot going on in this diagram here. Let's erase that. BD would be this guy here, this crevice, and that's 58 degrees. Okay. All right, next one. We're looking for the value of x and y in this rectangle. First of all, if we were to try to relate these two measures or expressions, notice they have different variables, so we'll be at a standstill. It's kind of stuck there. But I can relate 4x and the 20, because in a rectangle, these two have to be equal. So 4x just literally has to equal 20, making x 5. If I know that x is 5, I can substitute it in to my expression here. So 5 by 5, making 25 degrees right here. Okay. And then I know all together, these two have to add to 90. So we actually have that 25 that we just found, plus the 3y minus 5, all equaling 90 degrees, because that makes a right angle. So we have 20 plus 3y equals 90. So 3y equals 70. That's frustrating when we get decimals here. 70 divided by 3 is going to give me 23.3. Just approximation. Let's make sure that looks right. X is 5. It's 25. Because alternatively, we could have found that this is just 65, knowing that they have to add to 90 degrees. 3y minus 5 set equal to 65 will still give us that decimal. So, all right. The last one is more actually just an application of some properties here. So we're trying to determine which, based on the information below, which statements are true. Is it a rectangle? In order for this to be a rectangle, it needs to have 90-degree angles. We're not seeing the 90-degree angles. So no 90-degree angles that are actually labeled. Is it a parallelogram? Okay, we don't know based on the information that's given, but if we think back to all of our characteristics of parallelograms, remember that in our section on proving that a figure is a parallelogram, assuming opposite sides are congruent. Sorry, it's freezing here. Which we see with the 12x and 12x, 5x and 5x. Two sets of opposite sides being congruent makes it a parallelogram. So we already know it's a parallelogram, meaning the diagonals bisect each other. So this guy should equal this guy. That's not what this one's saying, though. 6x minus 4 should equal 9x plus 3. Or sorry, 6x minus 4, 5x plus 1. Not 9x plus 3. And then this one, 9x plus 3, should equal 10x minus 2, which we're seeing here. Cool. Let's go ahead and solve it to see if that is what I actually get for x. Okay, so if I subtract the x over, add the 2, x is 5. Whoops, not 8. Longest side has a length of 60. So if I take that 5 and I plug it back in, 12 times 5 is 60. So that checks off. Cool. Thanks for watching, guys.